Hi everyone, a very good morning to all. Today we are going to study about the refraction through a prism. It's all about prism. Now let's try to understand each and everything what is important related to the prism. Now the very first thing is what is prism? So prism is nothing but a device which can deviate light ray. So it can deviate the light ray through refraction. And when you consider a prism, see the actual diagram will be something like this. So there are two surfaces, like this is one and this is another one. So the two refracting surfaces, they inclined at some angle that I am representing here. That is called refracting angle. What we call it as refracting angle. So the angle between the two refracting surfaces, because here let's say the medium refractive index of the medium of prism is mu. Now once the light enters from the outside medium to inside, then it will undertake refraction. Then again here one more refraction takes place. One is from outside to inside, another is from inside to outside. So two refracting surfaces will be there, and such kind of device which can deviate the light twice through its two surfaces. So using which we can understand the dispersion phenomena. So that we call it as prism. Now the what is the basic thing we need to understand about this refraction through a prism is what is the deviation produced by prism for any light ray. Now this is angle of prism or refracting angle. Now a light ray falls on it at an angle. Let's take I. Now at first point, this is the actual path. Now the light will get refracted in particular path. Now this is the angle of refraction at first surface. Now here if you draw the perpendicular, then it will come out. So this is our incident light and this is our emergent light. Now here this is the refraction angle at the second surface, but as it is emerging out, we will take it as emerging angle or angle of emergence. And here it is angle of incidence at second surface that we will consider as R2. So that if you consider this triangle like A, B, C, D, E, first you consider triangle ABC. From that you will come to know that this is 90 minus R1. This is 90 minus R2. So 90 minus R1 plus 90 minus R2 plus A should be equal to 180. So that R1 plus R2 equal to A. This is the first equation. And this is the final ray. This is the initial direction. So there is some deviation that is called delta. Now delta is total deviation. So that deviation is delta 1 plus delta 2. This is at first surface. This is the deviation produced at second surface. Now in the first case, the deviation is from rarer to denser. That's why I minus R1. Then for the second case, denser to rarer. So R minus I. So E minus R2. So that the total deviation is I plus E minus R. R1 plus R2. Nothing but I plus E minus A. So this is the deviation produced by a prism when a light ray passes through it. Now here you can apply Snell's law also at every surface. Like at first surface, at first refracting surface, sin I by sin R1 equal to mu by 1. Or if you consider this is mu2, this is mu1, then mu2 by mu1. And at second surface, when you consider sin R2 by sin E equal to mu1 by mu2. So these are the equations you can make when a light passes through a prism. Now, the next thing what we have to understand is what is minimum deviation and formula. When you consider the deviation formula, it is I plus E minus A. As I changes, E changes, implies delta also changes. Now, when you draw a graph between deviation and angle of incidence, now the graph looks like this. That means at one particular angle of incidence, the deviation will become minimum, and that at that condition, the angle of incidence is equal to angle of emergence, and at that condition R1 is equal to R2. That means ray inside prism becomes parallel to base like this. It will become horizontal like this. So such condition we call it as minimum deviation. Now you take any other deviation value. There are two corresponding angle of incidence I1, I2. If I1 equal to I implies I2 will become E. So that deviation is I plus E minus A. And if I1 is E and I2 will become I, then also deviation is I plus E minus A. So the deviation is same for every set of two angle of incidences. That is what deviation. Now, in case of thin prism, so the deviation, minimum deviation will become mu minus 1 into A. And the refractive index formula will become sine of A plus delta m by 2 by sine of A by 2. Because at minimum deviation R1 is equal to R2, that value will become half of the angle of prism. So that these are the formulas related to minimum deviation. So many times they will ask question based on this minimum deviation condition only. So briefly I am explaining what are all the equations needed. What are all the equations based on which the question can come. Now, the next thing is what is dispersion and dispersive power of prism. So when you consider a prism, now when a white light passes through it, so now this is white light. White light is mixture of 7 different colors. So that what happens is it splits into 7 different colors. So the emerging light will be like 7 different. 4, 5, 6, 7. Now when you consider this, it will be like V, B, G, Y, O, R, V, G, R. So the red light will bend less and violet will bend more. And here the deviation formula when you consider mu minus 1 into A, so that delta V is greater than delta R, because mu V is greater than so on mu R, because lambda V is less than lambda R. Wavelength greater means refractive index lesser, as refractive index lesser means deviation less. So based on this formula, we will take the different deviations will be there. And when you consider the deviations here, so when white light is coming, now one light is deviating like this, another light is deviating like this. So from the original path, there is a deviation, like this is for delta violet, this is for delta red. Now there is an angle angular dispersion. That is angular dispersion means the angular separation between the violet and red light. That is nothing but delta V minus delta R. So the formula will become mu V minus mu R times A. So this is the angular dispersion formula. Now the next question they can ask based on dispersive power. So the dispersive power means, see how much greater, by what greater angle it can separate the colors. That is called dispersive power. So the dispersive power means angular dispersion for mean deviation or deviation for yellow. So that it will become like mu V minus mu R by mu Y minus 1. When they have not given mu for yellow, then you have to take average of violet and red. So this is what angular dispersion and dispersive power. So the angular separation between violet and red light is called angular dispersion, and the ratio of angular dispersion to the mean deviation, we call it as mean deviation, nothing but approximately we take for yellow, and that is called dispersive power. So the question also can be asked based on this dispersive power. Now the next thing what we have to understand here is, sometimes the question can be asked based on dispersion without deviation and deviation without dispersion. So when you arrange a combination of two thin prisms, so what can happen is, whatever may be the, so when you arrange the two prisms like this is A, this is mu, this is A dash, this is mu dash, same like here also. When light enters from one, then it will come out without deviation. So dispersion will be there, but no deviation. So the emerging rays parallel to the incident one. Or sometimes you will get, there is a deviation but no dispersion. So here white light will come out as white light only. So the splitting of white light into its constituent colors, we call it as dispersion. Here dispersion is there but deviation is there. Here deviation is 0 but dispersion is not 0. So deviation without dispersion without deviation. That means deviation produced by the first one plus deviation produced by the second one should be equal to 0. But here deviation is there without dispersion. There is no dispersion. There is no separation of colors. That means mu V minus mu R times A for first one plus mu V dash minus mu R dash A dash for the second one should be equal to 0. So this is the condition for dispersion without deviation, deviation without dispersion, and that based on that condition we will get the questions they can ask, like two different prisms made of two different materials with a different angle of prism. If they make one achromatic combination, then you may get one of these combination. So then what should be the relation between their refractive indices and their angle of prism? Based on that they can ask the question. Now sometimes they will ask question like, when there is a prism, so this is called grazing incidence. So when there is a grazing incidence, this is the normal, the condition is I equal to 90 degrees. Now similar way when you consider grazing emergence, so this is grazing incidence. Now this is grazing emergence. That means here E value will become how much? 90. Or you can also take normal incidence like this. Now I value will become how much? 0. Also normal emergence. Normal emergence means the light will go and falls here perpendicularly. Then E will become 0. Not only E, R2 also will become 0. Here R1 also becomes 0. And here not only I, R1 also becomes 90. Here not only E, R2 also becomes 90. So based on this condition means when a question is given and they mention grazing or normal incidence or emergence, then you have to take the values of E, R1 or R2 according to the given information. They will not specify what will happen. So then only you can solve the question using this data. This is also important. Now one last and final thing you have to understand here is sometimes they will ask question like one of the surface is silvered and the light is passing and it falls perpendicularly. So when ray falls on the silvered surface normally, then what happens? It retraces its path. It retraces its path. So in that case also normal incidence means E equal to R2 equal to how much? Sorry, R2 equal to how much? 0 degree. E will not be there because it is not emerging out. So when R2 is 0, then R1 should be equal to what? A. So that way you have to understand the condition. So these all things are helpful in solving the numericals. Let's see the questions based on whatever we have discussed. And I explained a lot based on this topic because many times they asked questions, and much more important topic in this chapter is very much important topic is prism compared to all the other topics. Now let's see the examples. The very first example is a ray of light is incident at an angle of 60 degrees on the face of a prism having refracting angle 30 degrees. The ray emerging out of the prism makes an angle 30 degrees with the incident ray. Show that the emergent ray is perpendicular to the face through which it emerges. See here, the prism you consider and the angle of incidence is how much? 60 degrees. A prism having refracting angle nothing but prism angle that is 30 degrees. The ray emerging out of the prism makes an angle 30 degrees with the incident direction. Means this is incident direction and then it is taking. Now this is the final emergent one. Now this is called the net deviation. So the deviation is 30 degrees. The ray emerging out of the prism makes an angle 30 degrees with the incident means that is the net deviation total. And we have the formula delta equal to I plus E minus E. I is there, delta is there, A is there. Now 30 equal to I is 60 plus E is, we don't know, minus 30. Now 30 plus 30 equal to 60 plus E. So E value how much? 0. E 0 means R2 is also 0. That means what? Normal emergence. I have shown the condition. So they are telling that the emergent ray is perpendicular. So E0 means what? Normal emergence. Normal emergence means what? The ray is perpendicular. So that will emerge like this now. So it will go like this. So that way you have to use the data whatever we have studied in solving numericals. Now the next question is, the refracting angle of a glass prism is 30 degrees. A is 30 degrees. Now, perpendicular to it, that means normal incidence now. Now the normal incidence means I equal to R1 equal to 0. Find the angle delta between the incident ray and the ray that leaves the prism. That means deviation they are asking. I plus E minus A. I is 0. So that E minus A. But as R1 is 0 and R1 plus R2 equal to A, now R2 equal to A. So that then here it came and fall here somewhere. Now this is R2 and this is E. Then you can apply sine R2 by sine E equal to mu 2, that is 1, by mu, that is 1.5. So that here what you can find is angle of emergence, because sine R2 is now A, sine E equal to 2 by 3. But here the thing is, sine E value you will get something like, see, sine E equal to 3 by 2, sine A is 30 degrees, 30 is 1 by 2, so 3 by 4. So sine E equal to 3 by 4 means E will be approximate value you have to take. Otherwise they have to mention in the question. Then you can calculate delta value, because A value is 30. E value you should know means you have to know the 3 by 4 value. So 3 by 4 means 0.75. So sine 60 means it is root 3 by 2. That means 1.86 approximately, 1.7 by 2. So 0.86, but this is less than that. So less than that means angle is slightly lesser. So approximate value you have to take. But in the examination, they will mention what is sine inverse 0.75. So that you can substitute that value, then you can solve it. Otherwise, they will not give such question. So if it is like, suppose it is root 3 by 2, then E will become how much? 30. Or if it is, 60 degrees, then the delta value you can find it easily. If it is known value came, like suppose sine E you got 1 by root 2, then E value will become 45. So if the regular known value came means no problem, you can do it. Otherwise they will give it in the question as data so that you can use it. Don't worry about such questions. Now the next example, the angle of minimum deviation for a glass prism. So mu is root 3 equals the refracting angle. That means delta M equal to A. What is the angle of prism? So the mu value formula is A plus delta M by 2 by sine of A by 2. Now if you substitute A plus delta M also A by 2 equal to sine A by 2. Now mu equal to, this is sine A plus A by 2 means sine A by sine A by 2. But here you need little mathematics, like sine A formula is 2 sine A by 2 cos A by 2 by sine A by 2 cancel. So that mu equal to 2 cos A by 2. Then if you take cos A by 2 equal to mu by 2, where mu is root 3 by 2. So that A by 2 will become 60 degrees. Because cos theta root 3 by 2 means theta should be, 30 degrees. Then A value will become how much? 60 degrees. So this way you can understand the question, then you can choose the formula and then you can apply the mathematics whatever required. Now one face of a prism with a refractive angle of 30 degrees is coated with silver. One face of a prism with refracting angle. So the angle of refracting angle is 30. Coated with silver. A ray incident on another face at an angle 45 degrees is refracted and reflected from the silver coated face and retraces its path. Now they are telling, see here, as I have mentioned the retracing path condition. So it falls here at an angle 45 and it went and fall on perpendicularly. That means R2 and E both are 0. So R2 and E both are 0 means R1 equal to A, that is 30 degrees. This is R1. Now if you apply the Snell's law, sin I by sin R equal to mu 2 by mu 1. Like this is mu 1, this is mu 2. Now this is mu, this is 1. Now you substitute. So sin I is 45. I value they have given. Now sin 45 by sin R1. So R1 equal to A, that is A value is 30, equal to mu by 1. So that mu equal to 1 by root 2 by 1 by 2 equal to 2 by root 2. So the value will become root 2. So this way you can apply procedure sometimes, you can apply formula sometimes depending on the question given. Here I collected the data. Then I understood that they have given one normal emergence condition. Because it is retracing the path means it should fall on the mirror at 90 degrees. So that then I came to know R1 value that is equal to A. Then I thought of application of Snell's law. So like that, one by one step you have to solve the question. Then we'll see one last and final question. A crown glass prism of angle 5 degree, that means A is 5 degree, is to be combined with a flint glass in such a way, another one A dash, such that dispersion is 0. So the dispersion is 0. So dispersion is 0 means mu V minus mu R into A plus mu V dash minus mu R dash into A dash should be equal to 0. Now refractive indices for violet and red light are for crown glass. So for first glass, mu V is 1.532, mu red is 1.514. And for the another glass, mu V dash, that is 1.632, and mu R dash, that is 1.614 for flint glass. Now obviously violet mu is greater than red light. Now they are asking the angle of flint glass prism, that means A dash value they are asking. From this formula, now A dash, if you take only magnitude, that is mu V minus mu R into A by mu V dash minus mu R dash. So just take the magnitude. So that all the values given. So just you have to substitute, then you will get the correct answer. Like that, the question can be asked based on deviation due to a prism or minimum deviation condition or the achromatic combination or silvering of one of the surface, or in meanwhile they can also add the grazing emergence or grazing incidence or normal emergence or normal incidence. So you have to understand the question carefully, then only you can solve the question. And similar kind of questions as I have given as an examples. So please try to solve them. Then you will get the idea like how to do the questions related to prism. And NCERT also there are 3 questions are there. So please just try to understand and try to solve them. So thank you all of you. Will continue in the next session.